I've built a picture of the network that is inside of my home office. I have a couple of routers. I have an internet connection. I have a connection right in the middle, which is this 10 dot network in the middle. And the other workstations on my network are connected to this 192 network. So I'm doing different things inside of my network. I'm actually NATing in two different places. There's a lot of different reasons for this because I have routers from different providers on different ISPs. It's probably not a normal configuration, but it does help us design a view of the world so that we can create some routes that would be associated with these stations and with the traffic that might be going through this network. Let's look at this workstation. Inside of this workstation is a routing table, and what I've done is break out individual routes so that you could see what every step might be along the way. And we can think about this process of how we might configure routes inside of our routing table. In reality, a number of these routing tables for these different devices would be a lot smaller, but I wanted to break out each individual network so that we could step through it. So this IP that we have down here is 192.168.1.22. It's connected to the 192.168.1.0 network with a /24 subnet mask. And you can see inside of that device, if it ever needs to get to the 192 network, and that 192 network destination is 192.168.1.0/24, the next hop to be able to get to that network is the local interface of this device, which is 192.168.1.22. Now, if it needs to get out to the 10 network, notice it's not directly connected to that 10 dot network. That means that if it needs to go to 10.1.10.0/24, the next hop is going to be this router, and the interface on this router has an IP address of 192.168.1.1. Now, there's also a default route that I've put here so that you could see that this workstation, if it needs to go anywhere else, which means that it can go to 0.0.0.0/0, which means anything else out there, you simply need to go to 192.168.1.1. And because that's a local router, that's the place that that workstation will go to get out to that network. Now, obviously, I could have taken this 10 network and the default route and combine it into a single route. But again, I wanted to break this out so that we can see the differences. Let's go to the next route that's then up the line and see what the differences are in its routing table. This router is connected to two different networks. It's connected to the 192.168.1.0/24 network, and it is connected to the 10.1.10.0/24 network. So if any traffic going into this router needs to get to the 192 network, it's local to us. If it needs to get to 192.168.1.0/24, simply go out my local address of 192.168.1.1. Similarly, if any traffic needs to go to 10.1.10.0/24, that is a locally connected network to me. You simply need to go out my local IP address of 10.1.10.14. Now, if traffic is going somewhere else, for instance, it's going out to the internet somewhere, then we need to have a default route inside of this router that says if you're going anywhere else of 0.0.0.0/0, then you need to go to the next router up the line, and its IP address is 10.1.10.1. Now, notice in my view, I have not put any metric numbers on any of these routes just to simplify things as we're going through this. Obviously, each one of those routes would have exactly the same cost associated with them because there are no duplicate networks. There's no way to go through a different network to get out. But if we had redundant routes inside of this and there were different interfaces that you could go out to get to the same place, we might set different metrics so that we could set one route to have precedence over another. If we go up to the router that is directly connected to the internet right up here, it has a 74.208.221.234 address on the outside, and it has a 10.1.10.1 because it's locally connected to that 10 network. So let's look at our routing table. If we need to get to our 192 network, obviously we're not connected directly to the 192 network, so our next hop is going to be 10.1.10.14. If packet's heading down to the 192 network, we're telling it inside of this router that you need to go down into this router for directions there. To go to the 10 network, though, we are directly connected to the 10 network. So to get to that network, you simply need to leave the local interface of 10.1.10.1. And if any traffic needs to go out to the internet, then we need to specify our ISP's router. So we've called our ISP, and our ISP has provided us with the IP address of the router so that our default route to 0.0.0.0/0 is always going to go to our ISP's router that has an IP address of 74.208.221.1. Configuring routing tables in a small network like this is relatively easy, but when you get into a large network where there are many different networks and you have different redundant routes to those networks, you might have different ISPs that you are using, then this gets to be a little bit more complicated. But you use the same process to determine where traffic is going and look at where your next hop is every step along the way. Whether it's a big network or a small network, it's exactly the same process. And when you're working on configuring your routers, you'll find that you'll do exactly the same thing. You'll examine the packets as they're going out and what routes they might take, and you'll examine as the packets come in and the routes they take to come into the inside. And as long as you follow those steps all the way through, you'll have some routing tables set up in your devices that will work perfectly for your end users.